Welcome back for those of you following the Living Island and anyone just joining. Last time out I spoke about forest biodiversity, and I'm going to continue in this week as well. Biodiversity in a functioning forest has to be conceived as complex and adaptive. It's a biological system where everything is interacting with one another, and yet cannot reach a point where it just kind of sits on its laurels. It has to adapt to minor changes and major changes. And what we're doing on the island this past summer, in order to monitor and report on what we call indicators, those plants or animals that are telling us the complexity is breaking down, or more adaptation needs to be done, or big change is coming. Literally, a constant flow of data is crucial. Genetic diversity is the basis for organisms through evolution to adapt to changes in their environment through natural selection. Basically, those that can change survive, those that can't either move on or die out. Populations with decreasing variation are most vulnerable to negative impact, even the risk of extinction. Now, as we all know now, looking at, say, the Amazon, various factors influence forest biodiversity. You have climate change, the environment quality, is it optimal for growth and reproduction? The water quality, air pollution, toxic waste, all of these things which tend to be generated by humanity are affecting plants and animals, because evolution has brought them to a point where they're not prepared to deal with us. I mean, that's what it comes down to. Common denominators include, if you're going to work with nature, is the preservation of habitats, understanding endangered species, understanding invasive species. We have one on the island, of a glossy buckthorn. It's invasive. But in a sense, you know, anything that came after the glacial meltdown invaded. So will glossy buckthorn be a negative or a positive influence? We have to wait and see. It's been estimated, and I shudder at this, that by 2050, I'll be dead. That's 30 years from now. My grandchildren will be, well, the oldest one will be in her 50s, and the youngest one will be in their 30s. Well, mid-30s. They're going to, you know, be younger than I am right now. And it's estimated that anywhere between, and this will be different in global regions, anywhere between 15 and 40% of species globally will be committed to extinction. 15 to 40% of what is alive now won't be in simply 30 years. I have no way of dealing with that, trust me. The modern concept of sustainable forest management includes these factors. The social. When you go over to the island, how does that affect the Miramichi area here? Economic. People go to the island, but they buy gas, maybe go to a restaurant. How are we affecting the environmental, the cultural, even I'll term it spiritual value, but even psychological. They both mean the same thing in a sense. It's not just how I feel, but how I respond and how I live. Let's break that down so we know what we mean by those terms. First of all, there's an organism. I don't care if that's a blade of grass, a moose, or whatever, or even me. It's an open system that continually interacts with the total environment. In a sense, we don't, because we have houses, we have cars, and we're not interacting. But every animal and plant continually interacts with its environment. Then there's a population. And that's organisms of the same species occupying the same habitat. So you'll have an area, this is growing in it, or this is running around in it. That's the population. Then there's a community, where you have different populations of plants and animals, but occupying same habitat, probably larger, but maybe not. Simply thinking of it is, you live in a house, on a street, in a neighborhood, in a town. So does every plant and animal. They just don't see it that way. Then you throw in climate, temperature, wind, water, light. These things they all have to deal with in order to survive. Then you have what's called an econiche. Every species has to have resources in that habitat. And how is that species fitting into that ecosystem that it finds itself? Is it going to be optimal for growth and reproduction and longevity, or was it a bad choice or just a bad roll of the dice? In any area you have a dominant species. Now, on the island, a lot of people look at the big white pines and say, oh, they're dominant. Well, they dominate, that's for sure. But this is actually, dominant species has the highest biomass. And when you look at that, again, who has the biggest volume? And do they, and if they do, how do they control the resources of that habitat and the competition that takes place for those resources? That's a dominant species. But then there's a thing called the keystone species. And a keystone species might not have the biomass. You may not even know it's there. But it has a specific ecological role that kind of controls that flow of energy. And if that's taken out for whatever reason, that whole system could break down. That's the keystone. And then you have what I would call ecological time, that seasonal adjustments year after year, how that influences evolutionary time, as well as evolutionary time influencing the ecological time. So basically what we're looking at then is, and this is what we're doing on the island, indicators are needed to test these things. You need to understand trends in selected biomes, ecosystems, habitats, trends in abundance here, distribution there, even changes in the status of maybe threatened species. Are they just not making it? Are they the failures? And in order to kind of monitor all of this, you set up a core curriculum like they do in school. You know, if you want a kid to graduate in grade 12 with a sense of what's going on, you have a core curriculum. Well, we do there too. You have to look at the genus that you're dealing with. You know, what is this species called? What are the habitats and subhabitats? Abiotic conditions. These are the non-living things that, like wind and rain and stuff like that, that these species have to deal with. As I said once before, the trophic levels, basically the food change from the primary to the ones that just turn it back into chemicals. You have to have spatial characteristics. Is there a minimum area for a viable population? If not, is it viable? What about a dispersal range for seeds? If you can't do it, you don't have a future. Sensitivity to human pressures. Simply by going on the island, which is why we tell people, stay on the trails. Because if you leave the trails, you're interfering with all of this. You don't realize it, but they don't like to be stepped on a heck of a lot. What are the common, the rare, the threatened species? We have to understand that. A species that is unique to a certain niche, which could be no more than 1 meter square, literally, in a defined geographic location. If that little thing changes, that goes. That's how important and specific it can come down to. Again, what's indigenous to the ecosystem, what's invasive, to understand how they're going to react to one another. All of this is to simply understand and to know what you're looking at, knowing where to find it, knowing how it's functioning, and knowing why it's there in the first place. It all adds up to understanding what's happening in a given location. It's as simple as that. And that's why we make these 1 meter squares. And okay, what's going on? This is the neighborhood we're looking at. What's going on in there time after time after time. You monitor that. And this is phenology. And that's what we're doing on Beaubears Island in relation to climate change and how it's going to affect biodiversity. So, as I've said before, I invite you to join us in whatever way is possible, either through the internet or feet on the ground, and whenever it becomes possible due to COVID. But until all those things take place, I ask seriously, support us, look at Patreon, give us some comments, let us know how we're doing, what you think about it, and if you can, give us that support. Until next time, take care.